All right, folks, this is lesson 211 in your notes. This is on essentially sequences. So we'll start off by giving you a pattern and then you continue the pattern. This one says use the process given to find the next three numbers in the list. So the process is multiply by 2. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. 48 times 2 is 96. Just a heads up, next year in Algebra 2, they're going to do the same exact thing, and they're going to make it look really scary. So what they're going to tell you is you need to say where the pattern starts, which is 3, and then you need to say what you're doing in the pattern. So here it says multiply by 2. So next year, what they're going to do is they're going to make some really ugly notation. They're going to call this an arithmetic sequence. This will be your first unit next year, the arithmetic sequence, and they're called recursive. Recur means like happen over and over and over again, just like a pattern happens over and over and over again, okay? So real simple, if I tell you to start a pattern at 3 and then multiply by 2, right? You go 3 times 2 is 6, times 2 is 12, times 2 is 24. Simple enough. Next year, what they'll do is they'll call this u sub 1, which means the first term. The first term is 3. Then they're going to say to find the next term, n, look to the one before it and then multiply by 2. So they're going to make you guys write it like this, but all they are saying is start at 3 and multiply by 2. That's all it means. And I actually lied. I lied. They're going to call this one a geometric. Sorry, not important for you to know for right now, but this is going to be called a recursive geometric sequence. I apologize. When it's multiplication and division, it means geometric. Okay? So then, if we look at this one where it says add 2, the first term is 12, and the pattern is to add 2. Okay? So what we're going to do is 12 plus 2 is 14, plus 2 is 16, plus 2 is 18, plus 2 is 20, plus 2 is 22. Next year, this is the one that they will call an arithmetic sequence, because when you add or subtract, it's called arithmetic. I don't know, I don't make the rules, they just did it. But again, you have to say where to start and what's the pattern. They assign some weird notation though. They say u sub 1 is this, u sub n equals u sub n minus 1 plus 2, and that's your recursive, okay? Just so you're kind of familiar next year, when you see this, don't panic. It's just exactly what we're doing now, finding patterns. So the next one, our pattern is a little bit uglier. It says add 2, then add 3, then add 4, etc. So 12 plus 2 is 14. 14 plus 3 is 17. 17 plus 4 is 21. Then we go plus 5 is 26. And plus 6 is 32. Okay? Next one is called Fibonacci. So you guys can Google Fibonacci, pretty cool guy. He's an Italian. He found some weird pattern. And basically, it has to do with flowers, flower petals on flowers, and apparently rabbit population, I just found out. So lots of little things follow the Fibonacci sequence. But basically what it is if you take 3 plus 7, it equals 10. And then 7 plus 10 equals 17. And then 17 plus 10 is 27. And then 17 plus 27 is 44. So basically what you're doing is adding the two previous to get the next number. Okay? This one probably going to be on the test, so I'd maybe make a note about this one. All right, this is another one that's probably going to be on the test. Hint, hint, nudge, nudge. So perfect squares are numbers that you can square root. So the square root of 4, the square root of 16, the square root of 36. The square root of 4 is 2. So basically what that means is 2 squared equaled 4. The square root of 16 is 4, which means 4 squared was 16. The square root of 36 is 6, that means 6 squared was 36. Now hopefully you notice it's 2, 4, 6, 8, 10, 12. So we'd have 64, 10 times 10 is 100, 12 times 12 is 144, okay? On the test, you may or may not be asked to identify this. We would call these the even perfect squares because it's 2, 4, 6, 8, 10, 12. Those are even numbers, okay? All right. The next one says add 1 to the numerator. Numerator is the top. Remember, numerator is the top. So we've got 1/12. It's like this. This one's 2/12, 3/12. You just can't put the line flat when you type on Microsoft. So this is like 4/12, 5/12, and 6/12. Now, you need to reduce these. In your calculator, if you hit the math key and hit frac, basically you need to hit math, enter, enter. Or if you have one of the smaller calculators, you hit the number, A, B, C button, and then the number, and hit enter. What will happen is it reduces this. So 1/12 reduces to 1/12, 2/12 reduces to 1/6, 3/12 reduces to 1/4, 4/12, here's what I mean by the math enter enter key. We'll reduce 4/12, I'll show you. So if you do 4 divided by 12, math, enter, enter, it reduces it to 1/3. If you do 5/12, it'll come out as 5/12. But if you do 6/12, 6 divided by 12, math, enter, enter, you get 1/2. Okay? So on your homework, there's one like this, where there's one line and then there's another line. The second line is for the reduced fractions. All right. So this one is where it gets a little bit trickier, but not awful. Basically, we have n's 1 through 6, and we need to put it into this equation. So we're going to go 5 times, in this case, n is 1, plus 3. So we've got 5 plus 3, which is 8. The next one, we're going to go 5 times n plus 3, and in this case, n is 2. So we've got 10 plus 3, which is 13. Then we go 5 times n plus 3. In this case, n is 3. So we get 15 plus 3 is 18. What you might notice is our pattern is plus 5, plus 5, plus 5 because of the slope. But if you don't notice that, it's fine. 5 times n plus 3, n is 4. Five times n is 5. 25 plus 3 is 28. And then last, 5 times n plus 3, n is 6. 30 plus 3 is 33, okay? I'm going to pause the video because I don't want to get cut off on the next couple. But basically, we just have a few more equations that we need to solve, okay? So I'm going to pause this and start a new video.